So in today's video, we're going to go ahead and delve into the definition of relative or local extremum. And before we do that, it's actually crucial that we revise the definition of a critical point. And so a critical point is just a point at which f prime of x is equal to 0 or f prime is undefined. And so essentially, if you want to think graphically, a critical point is a point at which f of x has a horizontal or a vertical tangent line. And then we can go ahead and take a look at a relative extremum, the definition of a relative extremum or a local extremum. And this is essentially just a critical point at which f prime changes signs and at which f is defined. So changes signs and at which f is defined. So what that means essentially is we took a look at kind of increasing and decreasing intervals, and we said that a function is said to be increasing over an interval if f prime is positive over that interval, or is decreasing if f prime is negative. And so when it comes to relative extremum, we just have to see when the first derivative of our function changes from either positive to negative or negative to positive at a particular critical point. And so I drew out a couple of examples over here so we can kind of just think graphically of why this definition makes sense for an extremum. And an extremum can either be a minimum or it can be a maximum. And so relative extremum would be kind of a relative minimum or a relative maximum. And we'll sometimes use the word relative, sometimes we'll use the word local. They essentially mean the same thing in this context. And so let's take a look at this first example over here. And so essentially, if we wanted to kind of just eyeball this, we can take a look at 2 points that appear to be extremum or relative extremum. We have this point right over here and this point right over here. And why are these points extremum or local extremum? Well, it looks like at these points, it seems as though we have kind of a horizontal tangent line, right? It looks to be like within a sort of neighborhood, this is our maximum value, right? And then over here, it looks like within this neighborhood, we have a minimum value, and we also have a horizontal tangent line over here. And so by our definition, a critical point at which f prime changes signs and which f is defined, we know that we're defined at this point, definitely. And we know that this is a critical point. So over here, we have a critical point. So this is a critical point. And over here, we have a critical point. And the reason we know that is because of the fact that we have a horizontal tangent, or at least kind of just visually, it looks as though we have a horizontal tangent line. So we have critical points. So we met this first condition over here. And now if you want to think a little bit about this, why does it make sense that this is a maximum given this definition over here, or a minimum given this definition of a relative extremum? Well, does f prime change signs? And as a matter of fact, if we were to kind of look at it, if we take a couple sort of points before our critical point over here, if we take, for example, this point and we were to approximate the tangent line, it may look something like that, right? So the slope is going to be negative over here. So we can say that f prime is going to be negative over here. It's less than 0. But then when we reach this critical point, the slope becomes 0, right? Because at this point, f prime is equal to 0, right? Because we have a horizontal tangent line. But then when we move a little bit after our critical point, it seems as though the function starts increasing again, and f prime is positive. So let me write that down. F prime is greater than 0 when we surpass our critical point. And so essentially, what happens visually is that when we're decreasing and then increasing, we have a relative minimum. So let me write that down. So if we go from f prime goes from decreasing to increasing, then this tells us that we have a relative minimum. And you can always think graphically, you don't really have to memorize this. And then if we look over here at our second critical point, if we look at some kind of the portion before our critical point, it seems as though, of course, f prime is positive. So here we say that f prime is greater than 0, so our function is increasing. We reach the critical point and we have a horizontal tangent, and then after the critical point we start decreasing, and so it looks as though it appears as though f prime is now less than 0. So then if we say that f prime goes from increasing to decreasing, this tells us that we have a relative maximum. And again, you can always just think graphically, like if we're increasing, then we stop, and then we start decreasing again, then we must have hit a maximum, if you just want to draw out an arbitrary example and then generalize it. Now, what about this example over here, the second one right over here? Well, if we wanted to use our same logic, let's see the extremum that we have. Well, looking at the critical points that we have, first of all, we have this point right over here. It appears as though we have a horizontal tangent. Maybe this point right over here as well. And at this point, we have f prime is undefined, right? Because we have a very sharp turn. And so these are all critical points. So these are critical points. I'm going to actually go ahead and erase the tangent lines now. And so essentially, what we need to do now is we need to first of all look for when f prime changes signs and where f is defined. So first of all, is f defined at all of these critical points? Well, no, it's not defined over here. So here we can say that f is not defined at this particular critical point, right? And so because of that, this is no longer a candidate for our extremum. So this is no longer a point that we're going to consider for our relative extremum. And then if we look at these other two critical points over here, so we know that at this critical point, this one over here, we know that f prime is undefined. And at this critical point, we have that f prime is equal to 0. But now what about f? Well, f is defined at both of these points, right? It seems as though we're continuous. It seems as though f is defined. And so because of that, we've now met these two conditions. We just need the final condition now to see whether f prime changes signs. And kind of just looking graphically, for this first critical point, the tangent line seems to be negative. We seem to be decreasing, and then we hit our critical point and we start increasing again. And so over here, we can say that we will have a relative minimum. Just using this little chart that we constructed over here, we'll have a relative minimum. And over here, it seems as though our tangent line, the slope of our tangent line is positive, our function's increasing. We reach our critical point where the slope is undefined, and then it seems as though we start decreasing afterwards. And so here we can say that we would have a relative maximum using the chart that we created. So I hope this helps you kind of become a little bit more familiar with the definition of a relative or local extremum, and why we use this definition, kind of the intuition behind this definition, at least graphically.